All right. Let's look at this briefly. These are some data from the census. Looking forward to updating this with 2010 census data soon. Okay, we're looking at education in the 50 states and the District of Columbia. And this is divided into a variety of slices through the population. Didn't finish 9th grade, 9th through 12th grade, high school grad, college, but took some college, didn't get a degree, got an Associate of Arts degree, got a bachelor's degree, got an advanced degree. Okay, so here we are for the 50 states and DC, and we're looking at a scatter plot of some college, went to college, didn't get a degree, divided by the total versus the total population. Okay, these are each normalized by 1,000 just to make the numbers more reasonable. So, who's that? These are, so there's, how many points are here? 51, right? 50 states plus District of Columbia. Which state has the largest population? Whoops, I meant to click that. Okay, that's us, right? We're the biggest. Okay. Okay. Are these data linear? They follow. They follow. Have linear association? Yeah. Generally, this is, if you put it, you could pretty much put a straight line through this. You think you'd underestimate that a little bit. Okay. Are they homoscedastic or heteroscedastic? So I'm hearing some of each. All right. If we take a slice through the data down here, is there much scatter? No, there's a lot of points that are nearly on top of each other down here. We take a slice over here, there's a lot more vertical scatter in the data. These are actually heteroscedastic. Okay. But less scatter down low than up high. It's kind of like the variability increases as the raw count increases. And there are a lot of phenomena that are sort of like this, but count data is often that way. Okay.
I had a question. I was wondering, when you say like homoscedastic and heteroscedastic, doesn't matter like which way it's scattering. Like say like the plot before, it kind of like the scatter was less as you went up higher. Doesn't matter.
Okay. So the question is, does it matter which way it goes for homoscedastic versus heteroscedastic? That this one, it doesn't matter that more scatter was on the right and less scatter was on the left. What matters is that if you take a vertical slice through this stuff, some vertical slices have a lot less scatter than other vertical slices. When you try to eyeball the amount of scatter that there is in a vertical slice, you need to take into account how many points there are in that slice. So here, I mean, if I made the slice so narrow that I only got these 2 points, it wouldn't look like much scatter at all. But there's clearly kind of typically what's going on. The standard deviation of the values in a reasonably sized slice is staying about the same. It gets a little wider in the middle where there are more points. But still, if I looked at like how wide would a band need to be to capture kind of 2/3 of them, that would be about the same width band as I move up. Okay. So scatter is not, I mean, there's only 1 point in this slice. It has no scatter because 1 point doesn't have any scatter. But you're kind of, on average, it's about the same amount everywhere. That's kind of what you expect in a football-shaped scatter plot. This figure is very different.